Okay, so we are looking at ionic compounds, naming and formula writing. Ionic compounds, naming and formula writing. So for formula writing, write the symbol and charge of the cation, the metal, first, and the anion, which are non-metal, second. Crisscross, only the number of the positive charge to become the subscript, and only the number of the negative charge to become the subscript of the cation. Some scripts should never have a positive or negative down with it. And then you reduce to the lowest ratio and write the formula. Now, we have this addition to what we had just been dealing with. Writing formulas of ionic compounds has one important difference. If there are, or multiple polyatomic ions, we need to balance the overall charge in the formula and then enclose the formula of the polyatomic ion in parentheses. All right. And then, if needed, write the proper numerical subscript to the right on the outside of the parentheses. So, if you were to look at, for example, calcium, always a +2 charge. All right. If they said, hey, you need to use calcium nitrate. Nitrate, if it ends in 8, guys, it's a polyatomic ion. If it ends in ite or 8, that is a symbol, or it should be a hint that it's a polyatomic ion. Your IDEs, for the most part, are all these except for cyanide. All right, that is pretty much the only other one that ends in IDE. All right, so nitrate. We look here, it's NO3, and that has a -1 charge. So we would do this. NO3, -1 charge. Similar things, all right, we take the number and we write it out like this. Okay, you take the number, not the charge, and you would drop it behind. Ca1. Now this 2 would then come behind the NO3. Remember, we don't write ones, so does this make sense, guys? I have CaNO3 It looks like what? How many oxygen does it look like I have right there? That is ridiculous. All right, so here's a little hint. If it goes above probably the most that I've seen on as far as an ionic compound goes up to maybe a 7. All right. Hold the phone. Wait a minute. We did something wrong. So the only other thing is there's a rule. If I get more than one polyatomic ion, you need to put parentheses around it. So put parentheses around the polyatomic ion. And now that's telling me I have 2 NO3s. I have 2 nitrates. I'm sorry, yes, 2 nitrates. So we have our CaNO3 2. So I only have 1 calcium right now. I have a total of 2 nitrates. So that's essentially what we're doing. Now, I don't distribute these and write it out like this either, CaN2 and O6, even though I do have technically in this formula here, I do have technically 1 calcium, 2 nitrogen, and 3 times 2, I have 6. But this is the actual formula. So what you would want to do is we're going to write the formulas. Zinc, always a +2. What does iron Roman numeral 3 mean? What is the charge of it? +3. Aluminum is always lead IV, which is 4, so +4. Ammonium, Mr. Lombardo, WTF, I don't know what that is. I don't know where that is. I don't see that. That doesn't sound familiar on the periodic table. Good, it shouldn't. It is one of the only positive polyatomic ions. So again, I said I would highlight some of the ones that we use the most often. All right, ammonium, sulfate and sulfite, phosphate. It's not on there, but phosphite. would be PO3 negative 3. We would definitely use hydroxide is used a lot. Nitrate, nitrite, cyanide, chlorate, chlorite, chromate is used enough, bromate, carbonate, and then acetate. So acetate can be written in one of two ways. This is the way that I prefer it, C2H3O2, but it is also written on numerous, in numerous textbooks or websites like this as well. So acetate can be either one of those two. I would say these are the ones that are used the most. Maybe hypochlorite, but I would say these are the ones that we use probably the most often. Okay, so with that saying, this says ammonium. Ammonium is here. It is NH4 with a +1 charge. Remember, this is all one thing. This is all one thing. So if I ever have more than one of these, all right, in my formula, it needs to have parentheses around that. Iron 2, Fe +2, and potassium +1. Sweet. Chloride is always what charge, guys? Nitrate. Okay, so it ends in an ATE. Guess what? That means it's going to probably most likely be a polyatomic ion. Nitrate is NO3 with a -1 charge. Oxide is always a what charge? -2. Nitride. So that's nitrogen, but as a ion, an anion, and so that would always be what? A -3. Phosphate. That is a polyatomic ion. Phosphate is PO4 with a -3 charge. And sulfite. It's not sulfide, so I got to look. Sulfite is SO3, -2 charge. So we're going to formulate. So I'm going to do a couple with the polyatomics just so we get an idea. All right, so ammonium nitride. So we have NH4 +1. I don't know why the heck that popped up. It's very irritating. Thank you for letting me know. NH4 with a +1 charge, nitride. N-3. So remember, NH4 is one whole thing. What am I going to do? What would the 3 do? 3 is going to go down where? Behind the NH4. So since NH4 is its own thing, you would write NH4, but now I'm going to have 3 of them. Does NH43 look good? No. Okay, if we have more than one of them, we put parentheses around it. And now this 1 would come down behind the N. But we do not write 1, so this is the actual formula for ammonium nitride. Okay, what if I don't have a multiple? All right, what if I don't have more than one of these polyatomics? So for example, if I said we went with aluminum 3 phosphate, aluminum. I'm sorry, not aluminum 3. It's just aluminum phosphate. So it's aluminum with a +3 charge. Phosphate is PO4 -3. Here's a hint, guys. If they have the same magnitude, so the same number, whether it's positive or negative, right? So +2 -2, +3 -3, +1 -1. Guess what? Here's a simplistical thing. You just rewrite the guys. So you don't need to worry about the crisscross here. So it's just going to be Al PO4. That's it. Because when you would reduce, right, it would crisscross. You would have Al3 with PO4 3, but it would reduce because they're both divisible by the same number. And then let's take a look at what about iron 3 sulfite? So iron 3, we have Fe with a +3 charge, and sulfite is SO3 -2 charge. So what is going to happen, guys? This 2 is going to come down and sit behind the Fe, and the 3 is going to come down behind the SO3. But remember, SO3 is its own thing. So, yeah, it needs to have parentheses. If there's more than one polyatomic, it needs to have parentheses. Plus, SO33 just looks ridiculous, so that should be a symbol of what we need to do. God bless you. Okay. Now, if we've done that, I want to go back here really quickly, and I want to just go through some of the actually, this is simple. All right, this is simple. This is the naming, but I wanted to give an example of naming one of our compounds. So I'm just going to do the ones that are on the board. You guys can get started. Okay, I'm just doing this for a video purpose. All right, so if we had, okay, this is not part of our assignment, but this is just something that's very good. If you had something like this, copper 1 nitride. Well, copper 1 is Cu. The Roman numeral indicates the charge, and nitride is always a -3. If you were to crisscross the charges, very simple, you would be left with Cu3N, and that's it. We don't write a subscript of 1. All right, but what if we got something that was like this? Cu3N2. I can't just say copper nitride because copper is one of the elements, all right, which I call has a split. It could have multiple charges. It could be copper 1, copper 2. It could be, something that's not listed on here, but these are just generally the most common ones of them. So I have to specify what it is. Now, how do I do that? Well, what I would do is the anion's charge never changes. So I look up the nitride is always a -3. Okay, so I have right now 2 nitrides. -3 times 2 is going to give me an overall charge of -6. Remember that ionic compounds need to have a overall charge of 0. So I need to have a charge over here of +6. Okay, what times 3 will give me a +6? That would be a +2. So this would be written as copper 2, Roman numeral, nitride. All right, or you could say, 6 divided by 3, it gives me 8. Boop, got it. Okay, and then let's take a look at one other one. If we saw this, PbO2. All right, so again, the charge of the anion does not change. So if you saw this, I would always say, okay, well, the charge of the anion of oxide is always a -2. So I have currently, looks like I have 2 oxides. So 2 times a -2 leaves me with a -6. I'm sorry, -4. Whoops. That means on this side I need to have a +4 charge. So currently it's the lead that is going to be dealing with all the positive charge. All right, the other guy over here is all of my negative charge. So the question is, how many leads do I have? There is no subscript written there, so it's supposed to be understood that that is a 1. So right now I could just draw that in. Okay, what times 1 is going to give me a +4? It would be a +4. So we would name this as lead. Since the charge is +4, we need to use the Roman numeral 4. And then whatever the hell our anion is, in this case, oxygen. All right, if it's the anion, becomes oxide. All singular elements, if they are an anion, get slapped with an IDE ending. So your nitrogen, oxygen, fluorine, phosphorus, sulfur, chlorine, selenium, bromine, iodine, these guys all become IDE endings. So if it ends in an 8, an ite, mate, I guess it's technically an 8, you should recognize, okay, those definitely are not normal. All right, that's got to be something that deals with a polyatomic. So, right, you see how they all end in 8, 8, ite, 8, 8, 8, 8, 8, 8, ite, 8, 8, 8, 8, cyanide. This is the only one that you want to make sure you know, like, okay, cyanide, that is a polyatomic, even though it does end in IDE. And then again, the rest of these are telling you what you need to do. So a vanadium 3, that would be a V +3 because of the charge, and selenide. All right, the IDE ending is an anide, so I would go to my periodic table. It should be a -2 charge. And we can always kind of look on the other side of our periodic tables that we've been given, and we get, boom, that is an SE -2. And when we crisscross this, the 2 will come down behind the V. The 3 comes down behind the SE. And you're good. But if we had something like this, beryllium oxide, beryllium, when we look it up, all group 2 are +2 charge. So beryllium is a +2. Oxide is always a -2. Now, if you were to crisscross this, it would be Be2. 2 drops down behind this is O2. Now, that's what the crisscross method gives us, but you have to know the other rule is that if you can reduce the charge, that's what you must do. And since this is able to be reduced, the final answer would be BeO, because they're both divisible by 2. All right, and that should go. Remember, if you do have multiple of your polyatomics, okay, they would need a subscript around them. All right, I'm sorry, a parentheses around them with the subscript, not like in a case like this, calcium nitrate, NO3 with a -1 charge. So you'd have CaNO3 with the 2 outside of parentheses, not just putting it after because it looks like CaNO32. Nope, not allowed. All right, this is the way that it must be written.